Hello, hello, hello. This is first a series. I think I'm going to do 3 or 4 of these videos on kinematic sketches. The purpose of this is if you can figure out the design of your robot, while from a sketch it's 10 times faster than figuring out how to design the robot by making 3D parts, assembling them, and then optimizing from there. If you have your sketch done into scale, then when you create the parts, it gets much easier to quickly generate your assembly and get your design done. So I'm going to start off with this video will be specifically about making a Cascade elevator. I'm using 2018 as the basis for this. So I'm going to create a sketch. Whenever you do your sketches, you want to start off with the constraints, the things that will not change no matter what. So I'm going to take this and put this to ground. And I had a wrong mouse click there. All right, so what are the things that we want this to do? The platform height was 4 foot. Was 4 foot tall in the down position, and the lip came down 3.5 inches, so we got 48 inches tall. Minus 3.5, minus 0.5 for a safety factor. That gives you the height that we're going to have to fit under when we have the elevator in the collapse position. And then we also need a target line to go to, and we need to basically get over 8 foot in order to deliver the cube. Another constraint or another part that's out there is let's assume that the clearance in between the bottom of the robot and the floor is 2 inches. So I'm going to start and put a sketch in, zoom in, and come in and put a rectangle in. Delete the top line. Put a constraint in to align the let me constrain the line to the origin. I'm really concerned right now that this has got an offset to it. Don't like to do that. That's a little bit ugly. So I'm going to do an offset to here, and I'm going to connect the ends of Last year we ended up using 1-inch tube. I'm going to take the 2 tops across the top and make them the same level. And let's set this to 1 inch. So the offset's set to 1 inch, and this U-frame will be 2 inches from the ground. And I'm going to arbitrarily pick 18 inches for the width. Now, since each Cascade goes up a little bit more, I'm going to leave this length where I am right now and start the next stage. So the question is can we get by with a 2-stage? Alright, so now I've put this in, and I'm going to now constrain this to the origin. I'm also going to set the gap in between the two stages at 3/16 of an inch. That's about what we had last year. And then there needs to be some sort of length stuck in. And let's say we have 35 inches. And I'll put a dimension in between the bottom of the stage and the next stage. And I'll put that at 3/16, but that is going to vary as the elevator goes up and down. And you'll see now we're fully constrained. So if I take this and double click on it, let's say we have 35 inches, so we probably can move up 29 and get a 6-inch overlap and be okay. Looks pretty good, so let's move this back down. Okay, now next, let's put the next stage in. Oh, by the way, that stage would not be enough to reach the top, which was our goal, to be capable of making it up to the 8-foot mark. I'm getting a whole bunch of bad mouse clicks here. Going to do the same thing to constrain the center to the origin. That moved it up. And then I'm going to come in and set this to 3/16. Set that to 3/16. These dimensions probably need to go up. It looks like there's a fair amount of room to the top. And just to make this a little easier, I'll set that to, I'll make the first stage, the second stage equal the first stage. Now here's an interesting thing to do. I'm going to pull this dimension out, pull this dimension out. I'm going to set this dimension to the first one. So whatever gap, and in a cascading elevator, that gap remains constant as you go up. Now let's put a window in here. The window that's actually going to have the it's going to have the actual manipulator that will be grabbing the cubes. Put that to 1 inch. Once again, come in, go to the center. I'm going to do the same drill here. I'm going to set that to the bottom. Come over here, put the same gap in of 3/16. That looks a little bit big right now. So let's say that we're 10 inches tall. This looks a little bit wide too. Let's make that 15. That looks pretty good. Alright, so now here's the cool thing is if I set this to, once again, 29, it shows the full length and it indicates that we can make it all the way to the top. And then when we take the values and drop them back down, drop that back down to like an 1/8 inch, the whole thing collapses and fits underneath. It may not hurt to actually increase this a little bit. So let's say the more overlap, the more stable it is. So let's say we went to 39 inches. That actually looks pretty good. We're still got a clearance to our line. Let's bring this up. That's 1 inch down. We got 1 inch cascade in between the layers. This may actually need to be the cross members we were using last year with 2 inches. But the principle still applies. So let's move up 30, and this gives an indication of, so now, oh, we're above the top. So here, probably can put some iLogic in to fix this. We're above the top right now, so we can't go that high because the window frame is actually outside of the working range. Let's see if that falls within. Oh, still needs to go down a little bit. So that indicates the maximum height that can be attained. If the end effector was mounted up high enough, it could reach. Or the height of the individual sections could be increased. Move up to the top. So let's take the 39. We go to 40. Let's see what happens with that. So we're running into the constraint at the bottom. Let's do 39.5. That gets us just underneath. Let's set this to 39. Go back into here and try our 27.5, which indicates that we can make it to the height and meet the requirement. So this is one of the strengths of kinematic sketches. You can very quickly come up with the general design of something, prove it out in a sketch, and now jumping from here to actually making parts would go much faster. Modifying the 3D geometry and all the constraints that go along with it take a fair amount of time, and in under 13 minutes I basically ran the sketch. So hope this is helpful, and I'll be also producing one for hood intakes and a hood shooter, and also like to do a 2-prong, 2-roller big ball pickup. All right, take care.